So before we get started, I just want to remind you all that the slides are available online, and all the code will be on GitLab as well for your reference after. The question we're all here to ask ourselves is, how confident are you that you're not about to break production? And along with that comes the question, how certain are you that the changes you're about to make do exactly what you expect? That they meet all the requirements set forth by your PM, engineering manager, etc. Our goal is to be able to deliver software quickly and reliably. We talk about continuous delivery a lot, but how do we get there? There are many tools and techniques for building a robust deployment pipeline, and today we hope to add one more to your toolbox.
The services we build today often contain a large, complex web of dependencies. Our services need to talk to databases, storage buckets, connect to message brokers. We've got to make sure that we have all of our permissions configured correctly, and much more. There are a lot of moving pieces to make everything happen. How can we set everything up in a way to ensure that we have everything configured correctly?
While Sean and I were on the order management team at Nordstrom, we were faced with the challenge of how to continuously deliver an event-based architecture with confidence. It was a critical component to our ecosystem, and we needed to be able to be certain we weren't going to break anything. We're super excited to be here with you all today, sharing with you some of our experiences testing enterprise software.
So before we get started, let's just go over some quick fundamentals when it comes to testing. So our unit tests are going to focus on testing those internal implementation details of our application. So does this function I wrote behave the way that I expect? Acceptance tests, on the other hand, which you may sometimes hear referred to as integration test or functional test. These tests are going to test your entire service along with its infrastructure and make sure that they're behaving the way that we expect. So these tests are just going to interact with your service at the periphery. So given a particular input, do I get the output that I expect on the other end?
When testing a traditional microservice, the setup is pretty straightforward. We have some code that calls our service that's being tested and then validates the response. We often see this being done in a lower environment that's used for testing. The challenge with testing environments is that they often become a bottleneck for deployments. We also see it being a challenge for developers to replicate this environment for local development, and we see configuration drift between production and our lower environments.
Another barrier to implementing a robust acceptance testing strategy is that our architectures no longer look quite that simple. Our services are connecting to databases, sending messages out into the abyss, and much more. And on top of all this, our architectures are constantly evolving. How can we set up our infrastructure and our deployment strategy in a way and integrate that into our testing suite? Sounds pretty complicated.
Sure does, Sean. But we're going to use ephemeral environments to do just that. An ephemeral environment is a short-lived environment that we're going to spin up for testing and then tear down. Short-lived is subjective. So for testing, we're going to want this to be quick. If we're debugging or troubleshooting, we may leave that environment up for a little bit longer. The bounds of our environment are also subjective. To maintain agility, we're going to want to make sure we're only testing the particular microservice we're trying to deploy. That means we're not going to want to spin up every microservice or piece of infrastructure we have in production, but we may need to spin up some extra pieces of infrastructure to be able to properly validate our service. For example, if our service is writing an outbound message to a pub subtopic, we'll likely need a subscription to pull from that topic and validate that outbound message was sent.
So how can we go about spinning up one of these ephemeral environments that Erin's talking about? So we're going to want to leverage infrastructure as code tools. So there's a ton of tools out there. There's CDK, CloudFormation, Ansible, Terraform, Pulumi, and many others. And you can even use bash scripts and a ton of sed if you'd like. But at the end of the day, we're going to need to provision our environment in a way that is consistently reproducible. This will ensure that we are provisioning our environment for our test in the same way that we are provisioning for production. So one of the first things we're going to need is we're going to need a unique way to identify our environment. One of the ways that this can be done is just by configuring an environment variable and adding sort of a unique identifier to it. Next, we're going to want to make sure that our infrastructure is templatized. So this will allow us to associate specific tests and environments with their corresponding resources. So here you can see that we're doing that by just leveraging that variable that we configured in the previous slide, and we're using it when we go to define our infrastructure. Next, we're going to want to make sure that both our application as well as our tests are configurable. This is going to allow us to deploy that same exact version of our application to run our test against as what we will be deploying to production. And we're going to want to conditionally provision test-specific infrastructure. So these extra resources that we need to deploy for our test we're going to use them to make validations against our resources that are running in prod, or that we'd be deploying to prod. And lastly, we're going to want to make sure that we clean up our resources at the end of every test run, and this will make our environment ephemeral.
Each service is its own unique snowflake, and only you have the context to make the right call for your service. We're going to want to balance the speed of our test with how closely our ephemeral environment mimics production. A Kubernetes cluster takes significantly longer to spin up than a pub subtopic. To save time as well as money, we may choose to run all of our tests against one database instance, whereas in production, we'll likely want our own dedicated database instance. These longer-lived pieces of infrastructure can live in a separate repository and may even be owned by a different team. Using configuration, we can easily make these deviations between environments. There are no hard and fast rules here. Be sure not to undervalue your time. A faster acceptance test suite means a faster deployment pipeline, and often, in turn, a quicker time to recovery.
So today, we've put together a simple demo for you all to demonstrate the effectiveness of integrating acceptance testing with ephemeral environments into your deployment process. So our manager has tasked us with developing a service that receives a message. And upon receiving this message, we'll go ahead and take that message and place it in a storage bucket. And then if that succeeds, we're going to publish a notification about this message that other downstream services can subscribe to by publishing that message on a pub sub topic. So whenever we go about developing a new service, we want to make sure that we establish a solid deployment strategy up front. This is going to ensure that we're building in quality from day one. So before we get into the details of our service, let's go ahead and take a look at what our pipeline looks like. So for today, we're going to be using GitLab CI for all of our pipelines and the demo that you'll see today. Of course, you can apply any of these concepts to any CI/CD system you may be using. So here's an example of the pipeline that we have running on master, and it consists of 4 stages. So our first stage here is test and build. And this stage, it consists of 3 jobs. So we have one job called test that's just going to run our unit test. And then we have 2 other jobs that are building Docker images. So we're going to be building 2 Docker images. We're going to be building one for our acceptance test and one for our service application. And one important thing to note is that we will be using that same Docker image of our service application that we're going to deploy to run our test against as what we will be deploying to production. The next stage in our pipeline is our acceptance test stage. So this stage is the stage that is actually going to run our acceptance test as well as spin up our ephemeral infrastructure. So this stage serves as a quality gate, essentially preventing our application from being deployed to prod if any of our acceptance tests fail. So this will basically stop, a faulty application from making it into production.
So before we continue, I want to quickly introduce Pulumi a bit more, since it's the tool we'll be using to provision all of our infrastructure in the rest of the pipeline. Pulumi is an open source infrastructure as code tool that allows you to use a variety of programming languages to provision your infrastructure. We currently support TypeScript, Python, the .NET languages, and experimentally some other languages as well. You declare the infrastructure that you want, and then the Plumie CLI figures out how to get there. Today, we'll be using Plumie to provision both our Kubernetes and GCP resources, which will make it super easy for us to spin up our ephemeral environments. Now that we have a basic understanding of Pulumi, Sean will walk us through how we integrate this into our pipeline.
So coming back to our pipeline, immediately following our acceptance test stage, we've got our preview stage. So the Pulumi CLI comes with a command called Plumie Preview, and this is essentially just going to do a dry run of all the infrastructure that we're going to provision before we actually go to provision it. So it's going to give us an idea of what resources are going to be created, updated, or deleted before we actually go to make those changes. So many teams like to incorporate this into their code review process because it gives them a chance to validate all the infrastructure that's going to be changed and all the resources that are going to be changed before they actually move that to prod. And the final stage in our pipeline is Pulumi Up. So this is the stage that's actually going to go ahead and deploy our infrastructure as well as our service application to prod, assuming that all the other previous stages in our pipeline have passed, of course.
Okay, so quick recap of our demo architecture. We have our application that receives a message, it places it in a bucket, and then sends out a notification on PubSub. We're going to use Go to write our application, so let's go ahead and take a look at our Go code. So we're in our main.go file, and you can see we have configuration that we're taking in. We have this helper called getConfigurationValue. This is a helper function that just reads an environment variable, and if it's not present, it shuts down our application. This is because everything we do today is going to be configuration driven, and if those variables are not set, we've done something wrong, and we want our application to shut down. These are also what's going to allow our application to talk to different resources in different environments. We then set up our clients to talk to our GCP resources. And then we set up two handlers. We have a basic health endpoint, and we have our message handler, which is what we'll be acceptance testing today. Let's go take a look at that message handler. At the very top, you see that we read in the request body, and then we unmarshal that into an inbound request. This is just a simple JSON struct that has a message field. If we can't unmarshal it, we return a 400 to our clients because they've sent us something that's incorrectly formatted. We then write the message to our bucket and return the object name. That object name is used to create a new message alert, which is marshaled into bytes, and those bytes are used to write to the PubSub topic, as well as respond to our client, and we respond with a status accepted. Okay, so now that we have a basic understanding of our application, let's go back and look at our architecture. So this diagram is a little bit overly simplified. There's actually many more resources that we need to create to make this all happen. We need service account provisioned with the correct permissions. We need to get a key for that service account, which we're going to make into a Kubernetes secret and then volume mount to our deployment. We're also going to have a Kubernetes service with a cluster IP to load balance our application. So we'll use Pulumi to spin up all of these resources in a reproducible manner. Let's go ahead and take a look at our code. So In a subdirectory called infrastructure, we have our Pulumi program. We're going to be using TypeScript today, and the GCP as well as Kubernetes Pulumi providers. So at the very top, you see we're taking in some GCP configuration. This is what allows us to use the same program to spin up our Ephemeral environment in a test project and then spin up our production in our prod project. We then have some application-specific configuration. So we have our env, which is our name of our environment. And so in production, this would be like prod or production. For one of our Ephemeral environments, this is going to be like test 1, 2, 3. And then we also take in our Docker tag, and this is so that we make sure we're always using that same immutable image. We then have our global stack reference, and this is those longer-lived pieces of infrastructure that we talked about earlier. We have a Kubernetes cluster and a namespace we've set up. We also have a service account for our acceptance test, and this is what our acceptance test will use to make validations against the GCP resources. We also have this conditional statement below, which is the service account for our application. In a testing environment, we're going to use our test service account, and in production, we're going to want to use our production service account. This is how we can easily make deviations between our environments using configuration. We then set up a name variable, and this name variable is what we're going to use to name all of our pieces of infrastructure. You see, we prepend the environment name to it, and this allows us to easily identify all of our test resources, as well as make sure that we can spin up multiple ephemeral environments at once. So Sean can be running a pipeline, I can be running a pipeline, and since we each have our own unique pipeline ID, they're not going to conflict. We then set up our GCP resources for our application. So we're going to set up our topic and give our application permission to publish to that topic. We are going to create a bucket and give our application permission to create objects. We then set up this cluster provider, and this cluster provider you'll see referenced below, and it's what makes sure that we are deploying our Kubernetes resources to the correct cluster and namespace. So we've provisioned the correct permissions on our service account, and now we need to get a key. And we use that key to create a Kubernetes secret. This is the first Kubernetes resource we look at, so I just want to take a second to talk about it a little bit more. So it looks very similar to a Kubernetes manifest file that you may be familiar with. The structure to all of these are the same. Since we're using a programming language such as TypeScript, we're going to get some type safety, auto-completion, things like that. And we're also going to be able to reference that service account key that we just created above. So if we were using something else to provision our infrastructure, we may need a lot of bash magic to make this happen, but here it's as easy as just referencing a variable. Okay, and then we have our deployment. Once again, our deployment looks very similar to a Kubernetes manifest file. This is what's going to actually be running our application. You'll see we get some things like reuse and drawing out our code by creating those app labels above, which we can reference throughout our deployment, as well as in our Kubernetes service that you'll see below. Some other things to call out about this deployment. We have that Docker tag that we talked about earlier. We have environment variables that we're setting for our deployment. And we can reference that topic and bucket that we just created. This is what's going to configure the Go application that we saw earlier. And it's also what's going to make sure that we're always talking to the correct resources in the correct environment. And the last thing to call out here is that we have that volume mount where we can just reference the secret. The last resource we have to create here is our service. And you can see we're referencing those app labels, that cluster provider again. And so this is the same Pulumi program that will run for ephemeral environments as well as production. Let's go ahead and take a look at how we're going to acceptance test this. So since our service is not publicly exposed, We're going to use a Kubernetes job to run our acceptance test. This is a great technique to use when you're running CI from some external runners, such as GitLab CI or Travis. Our acceptance test will run in the job, and if our acceptance tests pass, then our job will pass. If our acceptance tests fail, then our job will fail. This is also what we'll actually be doing the validation to make sure our service is operating correctly. Let's go ahead and take a look at the Go code that is our acceptance test. So we have a subdirectory called acceptance. We have this acceptance_test.go file. You see that we're once again taking configuration in. Everything we do is configuration driven, so we want to make sure our acceptance tests are validating against the correct resources. We then have our happy path test, and we set up our clients to talk to our GCP resources. And then we create a test message. And at this point, everyone's a little bit concerned because we've looked at Go code, we've looked at TypeScript code, and you're wondering, are we about to look at some Ruby code as well? If you've worked with me before, you know that Ruby is actually my dog, and she often makes her way into all of my tests. And you're also wondering how awesome Ruby is, and you can go and blame this line of code and see that I was not the one that wrote it. Okay, so we then go and post a test message, and we validate that the status code was correct, the status accepted, and then we read the response body and validate that we can get that object name from it. We then validate that we've sent a message to PubSub, and that PubSub message contains that same object name that was in the initial response. And then we validate that the message is stored in the message is stored in our bucket, and that the message matches that message that we initially sent. The last thing we have to do is clean up the object. And this is because we want to be able to cleanly tear down our ephemeral environment. And we also have a side path test, which we post a message to that one in Marshall and validate that we get back that 400. Okay, so let's go back and look at our architecture one more time. So we've already looked at how we used Pulumi to spin up all those blue pieces of infrastructure. And now we need to conditionally provision 6 more pieces of infrastructure. We're going to need our job, we're going to need correct permissions, secret, et cetera. So let's go look at Pulumi and see how our Pulumi code to see how we've provisioned that conditionally. So the bottom of our index.ts file, so this was that TypeScript file that we walked through earlier. Right under that service, we have our conditional statement. And so we're using a programming language. It's as easy as an if statement. If our environment starts with test, then set up our acceptance test. And this doesn't just set them up, it actually is going to also run the job. Since production doesn't start with test, it won't set up our acceptance test for prod. Let's click in and see what that looks like. So you can see we're setting up a subscription for our topic. We are giving our acceptance test permission to subscribe. We're giving our acceptance test object admin rights. And this is so that it can go and delete that object like we talked about earlier. We then create a service account key and Kubernetes secret, just like we did earlier, except this time this is for our acceptance tests. And then we create our Kubernetes job. So our Kubernetes job is actually going to be what's running our acceptance tests. Some things to call out here, you see that Docker tag again, you see those configuration values easily being passed in. And at the very end, you'll see the dependency on our deployment. So this means that Pulumi will wait until our deployment is complete before it spins up the job. The default behavior of Pulumi will be to, when we run Pulumi up, to create all the resources for us, and that includes waiting for the job to run to completion. This is just the default behavior, and it's overridable, but it works really well for us because it means that with one Pulumi up command, we're going to spin up our ephemeral environment, our acceptance test, and just be able to look at the exit code to determine whether our acceptance tests have passed or failed. Made it through all the code.
Oh, awesome. Our pipeline has passed, our application is deployed to production, and business is out throwing a party. They're just celebrating all the new features that have been deployed, and our customers are extremely happy. And of course, we were able to do this by leveraging acceptance testing with ephemeral environments that gave us that confidence to move quickly.
Not so fast. Monday morning rolls around, and we have a new requirement. Instead of having our application write directly to the pub subtopic, we want our bucket to trigger the notification. This means the peripheral behavior of our application is going to remain identical, but we're going to have to change both our application and our infrastructure. Luckily, we've set ourselves up for success by creating a robust pipeline, and we'll be able to move quickly and make this change. So let's go ahead and look at the PR that we opened to make this happen. So you can see that we're removing our dependency on pub/sub for our application. Our application no longer needs to be able to publish the topic, but our bucket does need to be able to publish the topic. We need to create the GCP notification. And then we get to delete a lot of stuff. And I don't know about y'all, but I really like PRs where I just get to delete a lot of code. So we're going to remove configuration from our application. The handler no longer needs that topic. Removing it from our handler. Our handler doesn't need to write, and we can remove that write to pub sub helper. Okay, so let's go ahead and take a look at our pipeline and see how this did. Sean, it failed. What happened?
I don't know. Let's go take a look at our acceptance test job and see if we can figure out what went wrong here. So if we take a look at the output from our acceptance test stage, we can see that, you can see that we ran npm install, which was basically just bringing in all those dependencies that the Pulumi program needed to run. So we keep scrolling. We can see that we're setting up those configurable values that we've been talking about during the presentation. And of course, we ran Pulumi up. And here you can see that we're skipping the preview because this is just for our acceptance test. So we're just going to go ahead and just spin up all the infrastructure. So of course, this command deployed our service application, spun up all of our ephemeral infrastructure, and of course, ran that acceptance test job. So if we keep scrolling here, let's see. We can see that our job was running, and we can see that it failed. So let's see if we can take a look at that log output from our acceptance test job. Oh, so we can see it failed here. It failed when we tried to publish that message to pub/sub. And it looks like it expected a value, but it got nil. So it seems like our message payload was empty when we went to publish. So we can see a few more failures occurring here. These all seem to be related to the failure above, so we can keep scrolling. And everything looks good. And at the end, we are running our Pulumi destroy command. So of course, this is going to tear down all of our infrastructure at the end of the test. And that's it. So it looks like the issue was that our message was empty when we went to publish.
Yeah, so I've pushed a change that fixes this, and we'll look at the diff between the PR and the latest commit that was pushed. So we set payload format to none when it needed to be JSON. It's easy to miss things in code reviews. You think you've done things correctly, but until you've actually spun up an environment and run code through it, it's often difficult to know that things are working as they should. Let's go ahead and take a look at this pipeline. So we see it's all green, which is awesome. You see that the stages are identical to those stages that Sean walked us through earlier on our merge request. The difference here is that we don't do that Pulumi up to production because it's a merge request. We want to make sure we're validating everything correctly. So we've done our code review. We know our acceptance tests are working. Let's go ahead and look at our Plumie Preview and see. Actually, before we do that, can we scroll to the top? I just want to show. So this pipeline took 7 minutes and 55 seconds. We often see somewhere between 6 minutes and 8 minutes for a pipeline to run on a merge request. So it's pretty fast to be building our acceptance test, our service, running our acceptance tests, and doing our preview. Let's go ahead and take a look at our Pulumi Preview. So as part of our merge request review process, we can look and validate that our infrastructure changes are the ones that we expect. So we scroll, we see our Pulumi Preview, and then we can see a lot of the pieces of infrastructure are remaining identical. The difference is that we have a topic IAM binding that we're adding a notification. Our deployment is changing, which is as expected since our application has changed, and we're moving that topic IAM member. So this looks great, and it looks like our merge request is ready to be merged. Using ephemeral environments and acceptance testing, we were able to iterate quickly and meet our new requirements. And now it's time to wrap things up. Acceptance testing allows you to move quickly. If there's any doubt in your mind about whether or not you're about to break production, add another test. Automated testing ensures our application works as it should today, as well as 6 months from now, when you're out on vacation. They document the behavior of our service so that you, as well as future team members, have a better understanding of how it's meant to operate. And by being loosely coupled with implementation details, we can make sweeping changes to our application and still confidently push to production.
Using ephemeral environments with our acceptance test makes developers even more productive. Infrastructure is a critical component of our application. We need to be validating that our application is correctly interacting with its dependent infrastructure. Being able to run these tests before merging to master and being able to run multiple tests at once gives us those quick feedback loops. And most importantly, we encourage all of our engineers to use automated testing.
There you have it, another tool for your toolbox. I want to thank you all for coming out today. I'm not sure if we have time for questions. Nope. We'll stick around outside the ballroom.
Thanks again. As said, feel free to ask questions outside in the hallway, but we've got to move out for the next talk. Thank you.